Good morning, Mr. Anderson. Alright, so this video is about homework 4. Perhaps I'd like to give you some hints on it because it is about sum to product to sum is actually a very challenging topic. So perhaps I give you some hints on this homework and you try to do it on yourself. Well, meanwhile, just talking about question number 18, I would like to give you some insight. This is a very easy question. However, sometimes when you come across something like this, cosine 3x equals to cosine x, then perhaps you would like to try getting like theta equals to phi, so you get 3x equals to x or 2 pi minus x or wherever. Well, this is also a very very standard way. However, you may find it's not so easy to tackle this problem because you don't know the range easily. For 0 to 2 pi, and you may need to check many different values. So for this type of question, I would rather suggest you to use this cosine plus cosine or cosine minus cosine. Every time when you come across this type of question, you may try to turn a sum to a product, because after you have a product, then you can use the factor method to get this. Okay, how do you get this line? Because you can apply a equals to 3x into this formula, the one I'm highlighting. Okay, you can apply a equals to 3x and then b equals x, and you get the corresponding products, corresponding factors. All right, so you have to develop a sense that after you have sum to products, then the final expression will have a plus b over 2. It's just like the mean of the two things, 平均值啦. And the next one is the difference over 2. Now you have some products equal to 0, so each factor may equal to 0. So you get two different possibilities here, and then you can solve for x. There are many answers. Look at the final range. This range is 0 to pi, so it means that you do not give any answers out of this range. Look at question 21. You would expect to use the formula highlighted here. You see that originally you have a product of sine and cosine, sine 2x, cosine x. It means that you plug in a as 2x and b as x into this formula, so you get 2x plus x, 2x minus x, and you expect that there is one common factor that you will get, because after you have the sum a plus b, you get sine 3x here, and you can combine this sine 3x with the other sine 3x. Alright, so this is how you apply the formula. Remember, you have 1 over 2 because the original formula have a 2 here, so you divide 2 to the other side and you get 1 over 2. Next, you see there is a sine 3x here, so you can combine the two sine 3x together. You get this. And finally, it is just another question just like the previous one, because you have a sum. Actually, it's a difference, but just the same. You have sum to product here, sine minus sine. Then you can apply which formula? You can apply this one, sine a minus sine b. Here you put a as 3x, you put b as x, and then you can apply the formula and get a product of two things, one cosine, one sine, so you can solve for the answers easily. Remember that the final answer should also lie in this range, 0 to pi, but not to 2 pi, something you have to pay attention to. Here, I would also like to let you see the alternative way to tackle this problem. If no one forces you to use sum to product or product to sum, of course, you can also do in this way. You can break 3x as 2x plus x, and then you will see something happening. Because after you expand this using compound angle formula, then you'll get sine 2x cosine x, cosine 2x sine x. And you would expect to see there is one common factor here. Actually not common factor, exactly the same thing. So after you can minus this to the other side, then you can eliminate this part. You get only cosine 2x sine x remaining. Alright, so this is another way to tackle this problem. Actually, this is easier. So you do not actually need to use sum to product or product to sum for this case. This is another way that I would like to share with you. Now let's look at number 22. For this type of question, usually we cannot know the direct way so easily when we first look at this type of question. Perhaps we may try different approaches. For example, you can try turning tangents to sine over cosine, turning this also into sine over cosine. It is actually some possible way for you to try. When you do this type of question, I suggest you to make a draft first, because you actually write that out. Because after you're writing something, maybe you get stuck at some point and then you erase everything. And apart from that, you can also think of this. On the right hand side, you can see tangent 3a and cosine 3a, they may have some relationship. And if you are sensitive enough to this, you get sine 3a over cosine 3a. So that's the cosine 3a and the other cosine 3a can be eliminated. Alright, so this is also a very sensible guess. And on the denominator, you see some cosine plus cosine. And you can also suspect that are we going to use the sum to product. After you have the sum to product, this is you will get some cosine, the mean of that, and then cosine the difference of that over 2. It means you will get 2 cosine, the sum of that is 4x over 2, it is 2x, and then the difference of that is cosine 2x over 2, it is cosine x. Okay, so this is some draft that you can write before you actually hand-on do this question. So just now I already analyzed to you the right hand side. You can see that the tangent 3a and the cosine 3a can be simplified. So it is this step, right? You can get sine 3a, and then on the denominator you get cosine 2a cosine a. At this point you may not know what's happening, so now you can look at the left hand side. The left hand side, you see that that involves some tangent a and 2a and no any 3a terms. So you will suspect that are we going to change this 3a as 2a plus a? This will be a very good guess for you, and after you do so you will obtain this thing. Why? Because you can apply the compound angle formula for sine 2a plus a. Sine, cosine, cosine, sine. Okay, this is the expression that you will get, and the next step already gives you the left hand side, because after you take the sum of two fractions, the first part, and then the second part is the latter one, right? But both of them will share the denominator. After you do so, and then you will see the final result. Now let's move on to the real boss of this chapter, number 25. It is a question that is really challenging. This is the type that you will have triangle, so that's the interior angles would add up to pi or 180 degree. For this type of question, usually we kick off by having one of the angle in terms of the others. For this, perhaps we can use C as pi minus a minus b, or pi minus bracket a plus b. In fact, I think you can be more familiar with this type and you can directly change it as sine a plus b. You may do so directly without writing too many steps. Why we get that? Because you have pi minus theta for sine, then you get sine theta. This is a very straightforward guess for the beginning. Also, for this type of question, you may not need to follow my approach. There are many different approaches, but let me show you how I analyze this question. Of course, the first thing that you can try is using C in terms of pi minus a plus b. So if you start from the left hand side, you will get that. And the next line is also very straightforward. But after this, then you may not have too much idea. Of course, I tell you that this question appears in sum to product to sum. You may guess using these formulas. But if I don't tell you that it is in this direction, then perhaps you have no way. So how can you think? Because you can also use right hand side to start. So perhaps you can try looking at the right hand side to see whether it gives some insights on that. You may analyze the right hand side, this part, sine 2c. It becomes 2 times pi minus a minus b. Taking out 2 pi here, and then you have minus bracket 2a plus 2b. Using 2 pi minus theta for sine, you get quadrant 4. It means it is negative sine 2a plus 2b. It means you can now change your right hand side in your draft to 1 over 4 sine 2a, sine 2b, and then plus sine bracket 2a plus 2b. Next, how can you move on? You may use the double angle formula for sine 2a, for sine 2b. You may do so. However, very soon you'll find this may not help you too much, I guess. But instead, you may use the sum to product. Why you will guess that you are going to use the sum to product here? Because after you use sum to product, you can look at the formula highlighted here, sine plus sine. In the resultant expression, you'll get a plus b over 2. Here, a is 2a, b is 2b. So after you have the sum for sine 2a and sine 2b, you would expect to see the average of them. It means a plus b. So finally, you get 2 times sine a plus b, the average of 2a and 2b, and then cosine 2a minus 2b over 2. It means a minus b. And for the second part, you will guess that you use double angle formula. It's like sine 2 theta. Sine 2 theta is 2 sine theta cosine theta. Why I will have this guess? Because after that, you'll get sine a plus b for both terms. And you can take out this as the common factor. Comparing it to the left-hand side, you see something very similar here. So this would be a very educated guess. Writing this in the next step, after taking out the common factor 1 over 2 sine a plus b, inside the brackets you will have a sum of 2 cosines. Comparing this part to the left-hand side, cosine A, cosine B, then you would expect to use sum to product or product to sum depending on whether you start from right-hand side or left-hand side. If you start from right-hand side, you get cosine plus cosine here. You have the sum of that. It means A minus B plus A plus B is the sum. And then divided by 2, you will get cosine A. And for the second part, you have the difference of that A minus B minus A minus B. It is negative 2B over 2. Remember that in the lesson I already focused on the points that cosine negative b is just the same as cosine b. This is the things that you can apply here. And after that, I think you already can see that it is very similar to the left hand side. So you may try to use from the right hand side to check the left hand side, or you can try to expand both and comparing them. Of course, after you write these steps, you can start from the left hand side and then change everything to the right hand side. So I hope this will give you some insights and you can try to write the remaining step on your own. Okay, it means you can look at the expression on the right hand side now and you try to squeeze it 即係試下屈佢出嚟啦. Okay, that's it. All I want to share with you about this question. Number 28 is a very interesting question. So first of all, you try to simplify the left hand side and you get some better expression. For example, you can see cosine 10, sine 10, then you should suspect is it related to sine theta, cosine theta. If it is like that expression, then you have the formula sine 2 theta equals to 2 sine theta cosine theta. You have to be very familiar with this identity so that you can ring a bell in your mind to see whether you can apply that. Right, cosine 10, sine 10, you will get sine 20 degree, sine 2 times 10. But after you have sine 20 degree, remember you have the 1 over 2. It means for the first two expressions, you get 1 over 2 sine 20 degree. And you may check that whether this agrees with the previous line. And for the remaining two, sine 50, sine 70, I didn't change anything. And on the next line, you can look at the product to sum here. When you have a product of two sines, sine A, sine B, you will have some cosine A minus B, cosine A plus B. It means the difference of that and the sum of that. If you want to make something useful, perhaps the sum or the difference will have something similar to the other one. Let's say maybe 20 plus 70, then the difference will give you 50. And you may combine the first and the last one. Of course, you may also try to combine the first and the second one. Because the sum is 20 plus 50, you also get something related to sine 70 degree. Well, but I would suggest you to use the first one and the third one. Because after you combine them, the sum would give you 90 degree. It is a really nice number. And the difference will give you 50 degree. And see whether you can move on. Now it's like this. If you combine the first and the last, and you will get cosine. Cosine, the difference would give you minus 50 degree. And I already remind you that cosine negative value is just the same as cosine positive 50 degree. Since cosine 90 degrees is just 0 and you'll get a very nice number. And after that you can combine cosine 50 sine 50 degree together, and you also use the double angle formula and you'll get the right hand side. Finally, you try to use part A's result in B and you will get a very easy answer. You only need to know that sine 100 degree is just the same as negative cosine 10 degree. Why? You have to be very sensitive to some acute expression to give you 100 degree. What is acute value expression? You get 90 degree plus 10 degree. 10 degree is an acute angle. And after you do so, 90 degree plus theta, and the final result will give you cosine theta. But no, it is not negative. It is cosine 10 degree. This will give you the answer for part B. Now let's look at number 29a. You are going to prove this sum of three sines becomes the right hand side. I would suggest you to look at the formulas and see which one will give you something similar to the right hand side. For example, when you look at sine A plus sine B here, you'll get some A plus B over 2. This part, sine A plus B over 2, would be very similar to the part on the right hand side here, sine A plus B over 2. So a very educated guess is that you can just apply the sum to product formula for the first two terms. After you get that, and you will also have the cosine A minus B over 2 in the expression. But this is not something we want. But never mind, just try that. After you turn it into the product of two things, like this. And for the second part, sine A plus B, there are many ways to change that. Of course, you may use the compound angle formula. You get sine A cosine B cosine A sine B. But this is a good guess, but it may not be useful for the right hand side, because you see that on the right hand side there is no cosine A, no sine A, no whatever. You only have some half angle. How do you change that into some A over 2 B over 2? I think you can also think in this way, because on hand you also have the formula sine 2 theta equals to 2 sine theta cosine theta. For this part you can change it as sine 2 times A plus B over 2. This is it looks weird, but you should try this. Why? Because after that you get 2 times sine A plus B over 2 cosine A plus B over 2, and you see that there is a factor here, sine A plus B over 2, that you can combine with the first expression. After doing that, you will get some cosine A minus B over 2, cosine A plus B over 2. For these two, you can combine using the sum to product formula, and I believe you'll get the results very soon. So you can try on your own. For part B, this is a very standard way of asking in part B, because you can use the result of part A. Part A is already an identity that you may use for whatever A and whatever B. And quite obvious that you can plug in A as 4x, B as 2x, and A plus B becomes 6x. It is actually quite obvious. So after you put this to the right hand side, you'll get some sine 3x, and then cosine 2x, cosine x. They are just some products of things equal to 0, so each factor may equal to 0. And finally, after solving for each of them inside the range 0 to pi, then you get all the answers. Now look at the bonus question. I don't think this is especially hard, but you may try on your own. I don't give you too many hints. I only want to remind you about how to change this type of expression, 1 minus cosine 4x over 8. For this type of question, I think both sides you may start from. If I start from right hand side, it may be a little bit easier perhaps. If you start from the right hand side, I will remind you about the double angle formula of cosine. For cosine 4x here, you may think of these three expressions, either 1 minus 2 sine square theta, or 2 cosine square theta minus 1, or cosine square theta minus sine square theta. Which one may be useful? I want you to be more sensitive to that. Because you have 1 minus something. So if you use the the first one, 1 minus 2 sine square theta, then it would be more likely to be useful, because you have 1 minus 1 plus 2 sine square theta, and then you no longer have any constant terms there, and you only get 2 sine square theta. Alright, so let me show you the first step. I would suggest you to do in this way. 1 minus 1 minus 2 sine square theta, and theta is 2x here. And then you may continue to use another double angle formula for sine, and you will get the left hand side quite easily. And for part B, it is quite easy also, because you can use the result of part A, and then after you plug in here, you have some double angle formula, and you can simplify this easily, I guess. You can also use sum to product or product to sum. And the last one, you just need to apply the result of part B. You get this very ugly expression into part B here, and then you get everything. Not really challenging, you can try. So that's all the hints that I would like to give you. I want to say that the hardest question is always related to the triangle question. Means triangle ABC, and then C equals to pi minus A minus B. But the other one should be quite easy. Hopefully you can get all of them correct. Okay, see you.